Okay, here's warm up 10.7. So here we've got some different circles. Here I've got a circle with two chords that are intersecting inside of the circle. These could be diameters. They don't look like diameters, but it doesn't matter if the chords are diameters or not. But when you have two chords that are intersecting inside of a circle like this, there's going to be a relationship between the segments. So if I take these two parts, the 8 and the 9, and multiply them together, that will be equal to the product of these two parts. So, in other words, 6 times x is going to equal 8 times 9. Okay, and then so that means 6x is going to equal 72. And we can divide by 6. And x will equal 12. Okay. All right, it's a little bit different when you have segments that meet outside of a circle. So here this would be a tangent segment, and this would be part of a secant. But I've got these two, they're meeting outside, and the little formula I use for this is I take the piece on the outside times the whole thing, and I'll explain what I mean by that in a second. And that's going to be equal to the piece on the outside times the whole thing. Space there as usual. Okay, so let's look at this this segment first. So the piece on the outside here would be the x, right? The x is the piece on the outside. Now the whole thing is not going to be 5. When I'm talking about the whole thing, I mean this entire segment. So that entire segment, I'd have to use segment addition property and then postulate. And then it's x plus 5, so the whole thing is going to be the quantity x plus 5. Okay? When I'm looking at this other segment, the part on the outside of the circle is the 6. The whole thing is also 6, right? Because that's all there is. So on this section, I've just got 6 times 6. Okay? And then I'm going to want to solve this for x. So first thing I'd want to do is get rid of the parentheses. Over here I'll distribute. On the right side I'll just do the multiplication. So I've got x squared plus 5x is going to equal 36. Okay, and now I want to solve this for x. So what I want to do is set it equal to 0. So I'm going to subtract 36 from both sides. Now I've got x squared plus 5x minus 36 equals 0. Okay, now that I've got this equation set equal to 0, if I factor this, I'll be able to solve this using the zero product property. So that's my goal, to factor this. Okay, and if this factors, which it will, it's going to look like that. It's going to be in that format, and there's a lot of ways you can figure out what goes in the back. You could use a diamond problem for one, so maybe I'll do that. So a diamond problem, I'm going to put the 5 on top and the negative 36 on bottom. I'm looking for two numbers that add to 5 and multiply to negative 36. Don't forget to bring the negative with the 36. That's part of it. So then I'm kind of just thinking about different ways to multiply to get negative 36 using integers. Well, that's not going to, those two don't add up to 5, right? Neither do those two. So let's see, 2 and negative 18, or negative 2 and 18, those don't work either. 3 and 12, I'm going to run out of space to write all these. 3 and 12 won't work, but I can do something with a 4 and a 9. Okay, now one of these has to be positive, one has to be negative, and they have to be on screen too. Zoom out a little. Okay, so I'd want the 9 to be positive and the 4 to be negative. That way they add up to a positive 5 and they multiply to negative 36. So that's my winning combo here. Okay, and now I can use the zero product property. I've got two things multiplied together that equals 0. So that means one of these two things has to be 0 itself. It has to be 0 times something or something times 0. So either x minus 4 equals 0 or x plus 9 equals 0. Okay, and then I'll add 4 to both sides here. I'll subtract 9 from both sides here. Those are my two options, okay? But now wait a second. Let's look at the diagram. It's okay to have x be a negative number in general, but I can't have a negative length to a segment, right? So x can't be negative here because this segment can't be negative, that can't have a negative distance. It's a distance, right? So that means I just have to throw this one out, and that means I'm left with just that one answer. So this is an extraneous solution. It worked algebraically, but it doesn't work with the diagram, okay? So same kind of deal here on number 3. Maybe I should have done this one before number 2. But we want to solve this quadratic equation. So I'd first look, is there any common factor, anything that goes into all 3 terms? There's not. So then I would want to factor this like so. If you get a trinomial that's not factorable, you could still use the quadratic formula or complete the square, but we won't have to do that here. Okay, so I'm going to set up a diamond problem again. I'm putting a 4 on top, negative 60. Don't forget the negative comes with that. So I'm looking for 2 numbers that add to 4 and the same 2 numbers multiply to negative 60. So I'm kind of just brainstorming. You don't necessarily have to write all these down, but you kind of want to be thinking through them. Those aren't going to add up to 4, neither are these. Let's see, 4 and negative 15. Those don't work either, so let's try 5 and 12 would be another option. Those don't work. None of these are adding up to 4. But then 6 and 10, and maybe you hit on that one right away, and that's fine. So 6 and 10, I can do something with that if the 10's positive and the 6 is negative. That's my winning combo. Okay, and then I've factored it, but I still haven't solved it. Solved means what does x equal in this equation? Well, now I can use the zero product property. I've got 2 things multiplied together that equals 0, so that means one of them has to equal 0. So add 6 here, and then I'll subtract 10 here. Now in this case, I don't have to throw either of these away. There's no diagram, so nothing wrong with having a negative x value. There's never anything wrong with a negative x value. It's just if you get a negative distance, negative length to a segment, or a negative angle, or some measure of an angle, or something like that. Okay, so this next one, I'm going to use this same formula that we used on number 2. So the outside times the whole thing is going to equal the outside times the whole thing. Okay, so let's start with just the numbers. The part on the outside is the 9, right? And the whole thing, it's not 5. Remember, you got to add them together to get the whole thing there would be 14. Okay, and now let's repeat that process using the other piece. The other piece is a little trickier because we've got those binomials in there and we've got x's. So the part on the outside on this top path is x plus 1, the quantity x plus 1. The whole thing, you got to think about, well, what would all of this added together equal? Well, I've got x plus x, that would give me 2x, right? And then I've got 5 plus 1 would give me 6. So when I add those 2 binomials, it's going to be 2x plus 6. Okay? So now I've got this equation that I need to solve. First thing I would do is 9 times 14, which comes out to 126. On the right side, I'm going to have to FOIL this. I've got 2 binomials multiplied together. So f for first, so x times 2x, those are parts in front of their parentheses. X times 2x would be 2x squared. O for outside, the parts on the outside, 6 times x, 6x. Inside would be 1 times 2x, that's 2x. And last is 1 times 6, parts at the end of their parentheses. Okay, so I got it down to this. Okay, now I'll start cleaning this up a little bit. I can combine those over there. Okay, now I want to set this equal to 0, just like I did on number 3 and number 2. So I'll subtract 126 from both sides. Okay, so now I've got it down to this trinomial. This one's a little different because I have this coefficient in front of the x squared. And there's 2 perfectly good options. One thing, when I'm thinking about factoring this, I could factor out a 2 to begin with. All right, and that's totally fine. But what I would like to do, since this is an equation, I'm just going to divide the whole equation by 2 because that will get rid of that 2 right there. And these are all even numbers, so that works nicely. And I can take 0 and divide it by 2. It's just going to equal 0 over there. Okay, so now 0 equals x squared plus 4x plus 60. And now we can factor this. Oh, I was subtracting 126. I just noticed. Whoops. That should have been a negative 120 there. Okay, so sorry, this is negative then too. Okay, and now, hey, this looks familiar, right? Wait a second, I factored that right up there, right? So this is going to factor the same way number 3 did. I'm not going to redo the work because I got it right there. So my winning combo is going to be -6 and +10. Okay, and then when I use the zero product property, x would equal, well, x minus 6 equals 0, so x equals 6. And if x plus 10 equals 0, then x equals -10. Okay, so same two solutions I got before, but now I've got a diagram and I got to think, are both of those answers okay? Well, when you plug in 6, both these, for x, both these segments are positive, so that works okay. But if x is -10, well then I have -10 plus 1, that would be -9. Well, I can't have a distance of -9. Same thing, you get -5 for this distance, that doesn't work either. So that means this answer is extraneous, and that means only x equals +6 is a legitimate answer there. Okay. All right, that is the end of the warm-up, and I'll see you next time.